And we're good. Let's go. Okay, section 8.4. Turn there quickly. Color pens at the ready. You guys can already start grading what you see. Number 6, was that an easy 1 by 1? Go team. Number 16, main minus opposite. Number 44, solving it either way, you would have gotten 64. Hey guys, which way was easier, A or B? Yeah, I would definitely say B, because how many zeros were there? Yeah, there were 3 zeros. However, some of you guys might have realized they were trying to show you the differences of choosing the column with the most zeros or leaving the most zeros in, because some of you realized when you went to go solve, having 2 zeros in, oh, that one didn't work so well, but in a lot of the matrices would have made it possibly easier to solve with 4 than to solve with just 1. I don't know, it's up to you. But depending, some of you guys, A might have been easier because you could have had all those zeros and just done, oh, this guy times that guy times that guy. And maybe you would have liked that a little bit more. So even though it might seem like more work, maybe it really wasn't. Janelle?
When I got the type 3, I did the trick that you showed us, like the...
Oh, expanding it?
Yeah, but I got negative 64 and I don't know what I did.
Oh, struggle. Of A or of B? Or both? So you chose that column though, right?
Yeah, I did.
Okay, and then you had positive, negative, negative, positive, negative. You had the negative with the negative 2?
It came positive.
And then you expanded. Weird. Okay, hold on. Let's go to the board real quick. I'm going to scroll down just so that some of you guys can start checking the next ones, but... Oh, there's only one you can see. Read off the matrix for me, Janelle. So it's a positive 2 times 7.
7, 0, negative 6, 6, 1, negative 2, negative 3, negative 1, 4.
So that'd be positive 2 times 28 plus 6 plus 36 minus 0. It could have been that you didn't, well, hold on, let me write it first. 14. Oh, what am I doing? 18.
For the 6, I put a 0. For 28, 6, and 36.
You had a 0? Oh, yeah, I didn't even look at that. Going too fast. And then 0 and 14 and 18. Okay. So you end up with minus 32. I don't know. Because once you have the positive 2, then these ones are all positive, and the opposite way is all subtract. I like to keep it in nice little parentheses. And yeah.
Would it have mattered if I did the other type first, so if I put like 0?
Yeah, because you have to think main minus opposite, so you need the positive going this way, negative going that way. Does that make sense? There you go. Good question. You guys already checked 56? Go team. 62. Oh, that looked awful. Does anybody freak out for a second? Well, because it's saying that'd be easy, and then that'd be easy. And then you have this little guy, and I would have done the last row. So I think you got to choose. So they were just saying, why not do the first row? So it'd be 5, and those are all 0, times this guy. Then do, sorry, the first row. The first column, do 5, all those are 0. Then do the first column again, 1, and all those are 0. So positive 5 times a positive 1. And this one, third row, right? I mean, you didn't have to do it that way, but that's what I would have done. So in the third row, you would have had 5 times 1 times positive, negative, positive, positive, negative, positive, positive 2 times, and then you would have just had this little minor with 8 minus 18, which would be negative 10. There you go. Negative 100. Oh, yeah. No, I was saying like column 1, and then, hey, column 1 again. There you go. Number 86, that was super similar to what we did in class, right? Just main minus opposite, quadratic, factor, done. Shoo. Okay, any odds that we had questions on? No? Going once, going twice, and sold. All right, cool kids. Let's get back to that problem you guys were doing in your workspace. Turn to the back of your spirals again. Have your notes handy. Zoop, zoop, zoop. There we go. Got it. Go team. We just checked homework, guys, so just check out the video. Sound good? All right. They were doing this in the beginning of class in the back of their spirals. Collinear means all on the same. So then if we're like, okay, well, this must be collinear because they're on the same line, I could set up and put my 10 and put my 7, put my negative 2, put my 7, but what's the problem when I start adding my 1s? So what do? We don't know 0, 0's on there. We don't know any other points unless we find the equation and figure out what other points would match the pattern. But what if we just put an x and a y? What does this need to equal if they are collinear? Yeah. So technically what we could do is we could use the idea of a determinant and use an unknown x, y and say, hey, we want an equation anyway with a y and with an x. I wonder if this will work. Final answer would be probably yes. Positive, negative, positive. A positive 1 times the determinant 70 minus negative 14, which would be 84, I think. Hopefully someone's checking my math. Because for this one, it'd be 70 minus negative 14, 70 plus 14. For the next one, it would be 10y minus 7x. For the next one, positive, negative, positive, it would be 70. What am I doing? I did the wrong one. This is 84, didn't I? That's the bottom one. The top one should have been, I don't know why I did that 2 days in a row, negative 2y minus 7x. There we go. Is that better? Negative 2y minus 7x, then 10y minus 7x, then 70 plus 14. All has to equal 0. What do? Yeah, combine what we have. Oops, not plus, minus. 10y plus 7x plus 84 equals 0. So therefore, negative 12y is equal to, now, maybe some of you guys could have figured that y equals 7 was the solution the whole time, but I was wondering if you could figure out how to use a determinant to do so. Some of you maybe just kind of gave up somewhere along the line, but negative 2, 7 and 10, 7, the only way this could be in the same line is if the line is what? Horizontal. So that's how you could have double checked it to make sure that you're right. You could have also done point slope form. The slope would have been 0 over negative 12, so 0. So y equals 0, x plus b. But anyways, there you go. Does that make sense? It was just a little trippy problem. I thought it was kind of cool because it was just an application. And this entire section is applications. But what we saw yesterday was Kramer's rule. Easy for the easiest problems. Oh, well. Kramer's rule. Then area, which kind of went into collinear. And now we're to cryptography. But not cryptography in an all-inclusive way. super deep look at cryptography. Cryptography in general, I had a class on it in college. It was like a math elective I had to take, could take. It's just codes. So this is just one type of code. There are many different types of codes. There are shift ciphers. There are, that's one of the most basic that most people would think of. Yep. You probably want it, because once you write it in your notes, you'll be able to use it in homework. And you don't want to have to be flipping back and forth when you're doing these, I promise. On the test, when it comes on Tuesday, when the timing is appropriate, I will put on the screen 0 goes with blank, 1 goes with A, 2 goes with B, 3 goes with C, 4 goes with D. A shift cipher would do something like, oh, 1 goes with B, 2 goes with C. Different shift cipher might do something like 15 goes with A, 16 goes with B, 17 goes with C. But normal shift ciphers are the easiest to break. Yes. So I'll say it for a third time. Everybody write the alphabet. A shift cipher would change where the alphabet starts. But the nice thing with using matrices to code messages and using an inverse matrix to decode, as long as an inverse exists, if an inverse doesn't exist, well, it might be for. The nice thing about matrix codes are that 1 second E might be one number and another second E might be another number. Most codes would just kind of shift this whole alphabet. But then if you were looking at a message, and hopefully you'd see a lot of messages, if you just see one message, it might not be enough to really be able to decipher. But if you see a lot of different messages trying to decode what's going on, if E was always one number, like in this one E is 5, that one's pretty basic. But let's say everything was shifted and E was always, I don't know, 19. Someone tried to be tricky with the code. E was 19. If you were looking at messages, aren't there certain letters that are more commonly used than others? So couldn't you see what repeated numbers there are and be like, hey, I think that's an E or an S or a, and test it? So even if you shift this whole alphabet and try to be sneaky, as long as you keep on using the code or the cipher that you have, someone could break any sort of shift cipher pretty easily by just saying, oh, hey, look, I see lots of 5s, so I think that's probably either E or S, or, and then they could keep on trying other letters that are commonly used. Those are usually the two they would start with. They're like, oh, I think 19 is repeated a lot. Either that's an E or an S or a... But it's a lot cooler of a code if 1 second E might be 5, the next second E might be 13, the next second E might be 31, the next second E might be negative 120. You're like, what? With matrices, we can make it so that you cannot see much of a pattern at all. Because the letters are not usually the same numbers, even within the same message. So here's the idea. You have a message that you want to code. And with that message that you want to code, you go ahead and take the message, which is going to be in letters, right? And then you're going to translate or transfer those letters into their numeric equivalents. Just the super easy ones of A is 1, B is 2, C is 3, etc. If you guys notice, I had 2 different tables. There was one, then the other. I put them on top of each other, so I know it's awkward. But there were 2 different tables. I just put them on top of each other to be nice. I guess I could have written this way over here, but then it's small. Anyway, so A is 1, B is 2, C is 3, D is 4. You're like, well, that's lame. That's super easy to figure out. Okay, well, hold on. We haven't done any matrix stuff with it yet. So we're going to write our message into, or translate all the letters into numbers. Once we have the entire message translated into its numeric equivalent, then we're going to go ahead and I want you guys to circle the word encode. Encode. What does that mean? Get it into a code. Encode. You're going to encode by multiplying that message. You're like, well, multiplying the message. Well, we're going to have to kind of group things too. So number one, we're going to write the letters in letters, and we're going to group the message into rows of some sort of n that you're going to choose. The book's going to choose it for you, but if you were doing it yourself, you could choose how big you want the rows to be, whether 2 elements or 3 or 4 or 10, doesn't matter. Depends on how long your message maybe is. So you would group your message into rows. It might be nicely split up by words, or it might be like cutting words into pieces and having one letter of one word be here, another letter be down there. It doesn't matter. Group the message into rows. Then you're going to encode by taking now what we have as a matrix and multiplying it by whatever that n is, whatever you decide to choose the rows, the size you choose the rows to be of how many entries are there. Multiply by an invertible matrix. Just a hint, if you ever multiply by a non-invertible matrix, by a singular matrix, there's no way to decode it, which is kind of a bummer. But as long as it's invertible, and n by n has to be a square matrix, then you're going to have it all encoded, and the numbers are going to appear random. It's not going to be only within 0 to 26. It's going to be within all sorts of different things, because when you multiply matrices, you guys know you go cross down, you're multiplying and you're adding. It's going to look completely random. What used to be all 5s before for all the e's are now completely mixed up. And if you want to make it even harder, you could take it out of the matrix and just write a long string of them, so someone who saw it doesn't even know what size matrix you were working with. We were working with a 2 by 2 encoder, a 3 by 3, a 4 by 4, a 5 by 5, a 6 by 6, etc. The only way someone could decode, right? Get back to the original numbers, that could get back to the original letters. The only way someone could decode your message is to know, first of all, what size matrix was used to encode, and then second of all, what the inverse of that matrix is. Because only an inverse matrix can undo matrix multiplication. Only an inverse matrix can undo matrix multiplication. So, let's see if we can do this thing. You guys have the whole alphabet written down? You don't have to write this down unless you want to. Let me give you an example of the whole thing as far as message to encoded message. Okay? Message. Meet me Monday. Okay. They decided to multiply by this invertible matrix, which is a size 3 by 3. So therefore they said, okay, if I want to use this as my encoder, then I'm going to split these guys up into groups of 3. Take the first 3 letters, then the next 3, including the space. Then the next 3, including the space, the next 3, the next 3. What do you do if you run out of letters? Put a 0. Good. See the 0 at the end? Then they went ahead and said, M goes with 13, right, in your chart? M's the 13th letter of the alphabet. E's the 5th. E's the 5th. T's the, 20th. They grouped them into rows. Grouped them by 3s. Then they went ahead and, wait a minute. How did this, with that, make that? What was going on? What got multiplied? What did they do with this guy? Multiplied what? You could technically do it one at a time because it'd be a 1 by 3 times a 3 by 3. It's legal. You could do it that way. You could do the 1 by 3 times a 3 by 3. Or to save time, couldn't you just make a matrix? Thank you. Okay. And guys, as long as I only have 3 columns, as long as I've made the rows only 3 entries long, won't this be legal to multiply all day, however long your message is? And then what happens when you multiply this by this in your calculator? What do you get? That. And how would you make it even more complicated if you were trying to hide something? Couldn't you just write the message as 13, negative 26, 21, 33, negative 53, negative 12, with no rhyme and no reason, and they had no idea what size it came from, what matrix it came from, that you were even doing matrices to begin with? And why is that cool? Check it out. Do you guys see what I mean by 1, 2, 3 different 5s and 1, 2, 3 different zeros? Like, hey, I think the 5s might be E's. There were a couple repeated 13s, 1, 2, 3, so maybe you would have thought the 13s were E's for a second, that they didn't make it quite that easy. But either way, repeated letters are always something to keep an eye on, or repeated numbers, because you're like, oh, hey, I think that might be a blank or an E or an S or a T. And then check it out and be like, okay, well, if 13 was E, okay, then go back. Then 12 would be D, 11 would be C, 10 would be B, 9 would be A. Oh, okay, then make the whole alphabet and then try it and see, does it work? Oh, no, that message doesn't make sense. Okay, so maybe the zeros are E. Nope, that doesn't make sense if I do the whole alphabet and try to decipher it. Oh, maybe the 5s are E. Okay, so that way, if you see repeats, you can actually try to play around with it and see if you can figure out what the message was or how it was decoded. But if you just see all this random stuff, kiddos, all of a sudden my 5 and 5 became negative 26 and 21. I don't see any repeats. I'm not really sure what's going on. Now, question. If any message grouped into rows of 3 multiplied by this matrix got here, if this is the coded matrix, if my message has been encoded into this coded matrix, how would you decode it? Multiply A times B by the inverse. So whatever you got for your A times B, whatever you got for your coded matrix, you would be able to decode by just multiplying by the inverse. Because whenever you multiply by the inverse, then you're going to end up back to the original. And it's going to undo all that crazy multiplication and addition stuff that just happened. So if I multiply the coded by the inverse, and the nice thing with the inverse is it doesn't really matter what order you multiply it in. Remember, he's the only guy multiplied one way or the other where there's not a difference in that multiplication. Then you're going to end up back to the original uncoded matrix. Okay, so that's the idea. That's like the whole process. Yeah. Well, technically I just did it in my calculator, but if you want to see where everything comes from, remember you have to go cross down, right? So the very first entry is found from the first row with the first column. But you're asking about the second entry in the first row, which would be the first row, second column. That would be negative 26 plus 5 minus 5. Does that make sense? Okay. All right, so what if you were given something like this? What have I done so far for you? I gave you a message. I gave you the encoder that I wanted you to use. So what's this all? Because on your little chart, what does H go with? What does E go with? What does L go with? Okay. So go ahead. Ready, set. Get the example down. But this uncoded matrix has not yet been encoded. So use your calculator after you have the problem down to encode it for me. I started to save on. As you guys are writing the message, help is on the way. And as you're writing 8, 5, 12, 16, 0, 9. I was changing my letters into numbers. I was grouping my numbers by 2s because of the size of the encoding matrix. Once you're ready, grab out your calculators and encode it for me. Go ahead and read me your encoded message, or message matrix. Oh, we're still putting it in. That's okay. Just a hint with the cipher ones, with the coding ones. Where'd my pencil go? Aww. You would definitely be able to use your calculator. This would definitely be a calculator portion of the test, just in case you got worried for a second that you'd have to do all this by hand. The answer is definitely a no. What size matrix did you guys end up having to make for the message? Good. Ryan ended up being still gone today. Colby's still gone today. Otherwise, we're all here. Okay. So what's your encoded matrix? Just read it for me, line by line. First line. Negative 21. 29. Negative 40. 52. Negative 9. 9. 57?
Negative 38.
Got it. Sorry, negative 58, 38, 57.
44. 59. Negative 20. 20. Negative 21. 29. Negative 23. 23. Negative 27. 28.
There you go. What if you were given the encoded matrix? Because some of homework is going to have you go backwards too. What if you were given the encoded matrix? How would you be able to figure out the original message? Well, hold on, but you don't even know. If you were given this message right here, you can't just multiply yet because you don't know what size matrix. Is it rows of 2? Is it rows? Imagine you were just given this. What would you need to know? The encoder or the decoder. What would the decoder be? So if you were given this message, you would need to know the encoder, yes, and then find the inverse, or the decoder, and then not even know the original. Because I need to multiply the message by the encoder's inverse, aka by the decoder. So, kiddos, you know how to find the inverse of a 2 by 2. I know you have your calculator, but that's okay. Good practice. How do we find the inverse of that guy? Do you remember? You switch the, and then what do we do here? Switch the signs. But careful, that might not be the answer. What else do we need to do? So what's negative 2 minus negative 3? Negative 2 plus 3? Whew, all right, so that is my inverse, right? So if I knew that this was my decoder, which it is, if I knew that this was my decoder, what could I then do to this message? Oh, that's a 2 by 2. Therefore, I need to group this by, okay, so I could group this by 2s, kind of like we did at the beginning. I would need to know how to group it. Then I would put it in as a matrix. Then I would multiply. And what would happen when you multiply? The encoded times the decoder will equal the original message, right? Oh, the original message like with letters? You wish. No, the original message with numbers. And then what would you do with the numbers? Use your little baby table to go back. Does that kind of make sense, the process? How to encode or how to take an encoded message and decode? Like with any coded message, you usually need a key. The key in this one would be either the original encoding matrix or the inverse of that, the decoding matrix. Huh? Oh. Really? That's it? So guess what I want you to do right now in your group? No. I want you to encode a message, choose an encoding matrix, because you can't encode it without an encoding matrix. And then, once you have it, I want you to go ahead and use the workspace of someone else in your group to write the encoded message, giving them the original encoding matrix, and then see if they can figure out what your original message was. Okay, now hold on. Wait. Whoa. Everybody in the group needs to hide a message. Meaning, you have to make a message. Don't make it too long. Make it like one sentence. Less than like 30 letters. Encode a matrix. Encode a message. So you have to write a message first, then what? You have to multiply it by, well, okay, hold on, you're going to have to come up with a matrix. Okay, well then you're going to have to come up with what size of matrix, right? Wait, then you're going to have to check that there is an inverse to that matrix, or else if there's not an inverse, you just made an impossible message and you fail as someone who's trying to give a problem or a message to someone. So you have to check and make sure it has an inverse. As long as it has an inverse other than 0, you can use it to encode your message. Then you're going to borrow the workspace of someone else in your group, write the hidden message, the encoded message, give them your original matrix, and say go.
So you can use any encoded matrix as long as the inverse.
You can choose any matrix as long as its inverse is not 0. A 2 by 2, a 3 by 3, a 10 by 10. Ready, set, go. P.S. Turn in the back of your homework spirals to the workspace. That way, when someone's ready, they can steal it and give you a message. P.S. Make it not a mean one. At all? Go team. That'll be fun. Now pause. If there are 3 people in your group, are you going to have to be a little strategic and not just have 2 people write messages and the poor little third person's alone? Okay. Make sure that everybody... Yeah, it can be short. It can be like 3 words. Make it at least 3 words. No more than like 7 or 8. Yeah. Making up your own inverse matrix, or your own matrix that you want to use. Checking it has an inverse that's not 0. Multiplying it, giving the hidden message to someone with the encoder, and have them figure out the message. Yeah.
What if there's a comma?
You make up everything. Make up the message, put it into numbers, make up a matrix to use, multiply, give the hidden one to someone with the original matrix. Yeah, because we're still going. Thanks though, bud. Everybody's doing it, even if you don't have a calculator. Make a message. Everybody can write a message. You all know English. If you want to be really snazzy, you can put it in a different language, but that's just mean. Unless you know they're in that class, then it's not so bad. There's another one. Make a message. Okay, well hold on. Don't you have the alphabet? Okay, so take your letters, make them into numbers, right? Write out the numbers. They're not looking at what you're doing, so it's okay. You can write the letters if you want. Write out the numbers. You're giving them the mixed up numbers at the end. You're giving, and if you want to be really nasty, don't even like group it for them. Just write it out in a line.
Oh, I forgot we didn't put spaces too.
You do need to put spaces, otherwise that's mean. They have to figure out what your words are and where they break up. If we were pre-cal, maybe we've done some examples, but this is way more fun since we're honors. Make up a 2 by 2, 3 by 3, 4 by 4, but you gotta check it that its inverse is a number. Okay. Poor kid. You're like, wait. The finished product, either written in a matrix if you want to be nice, or written in a line if you want to be mean. Not mean, more like me, and a test question. And then you're giving them the encoder. Make them do the whole inverse thing. Yeah.
I'm not done yet. There's one left.
Well, that's okay. I mean, if you want to do by 2s, you can do that. And then just add a 0 at the end. Remember, you can add spaces. If you want to group by 3s, you can do that too. But remember, however you group it is the size matrix that you need to make up.